In this video, we'll explore what transcriptomics is, how it can be used in fisheries and conservation management, and what managers and resource users need to know to put this powerful tool into practice. Fish health matters, not just for aquatic ecosystems, but for fisheries, food security, and long-term conservation. The challenge is that stress isn't always visible. Fish face a wide range of stressors, including rising water temperatures from climate change and the resulting declines in oxygen availability. Freshwater salinization from road salt use is another growing concern. Contaminants and pathogens also threaten fish health. And one stressor that is often overlooked is handling, especially in captive reared fish or during stocking and release into lakes. Now, these are only a few examples, but what's important to remember is that stress can affect fish health long before we ever see outward signs. That's where transcriptomics comes in, by listening to what fish genes are actually telling us. By measuring gene transcription, transcriptomics allows us to see how fish are responding at the molecular level, revealing changes related to stress, immune function, metabolism, and many others. These gene responses act like early warning signals, uncovering the hidden impacts of environmental stressors long before visible damage even occurs. So what does transcriptomic data actually look like? Well, one common output is a heat map like the one shown here. Each row represents a gene, and each column represents a different condition, such as temperature, location, or treatment. The colors show whether genes are more or less active, allowing us to quickly see patterns in how fish respond to stress. Instead of relying on a single indicator, transcriptomics lets us interpret tens to hundreds or even thousands of genes at once, giving a comprehensive snapshot of fish health. For transcriptomics, the tissues you decide to target depend on your research or management goals. For example, if you're monitoring salinity-related issues and osmoregulation, gill tissue is often the best choice. If you're interested in how contaminants affect fish health, liver tissue can provide insight into detoxification processes. No matter the tissue, proper preservation is critical. Samples should be flash frozen in liquid nitrogen or preserved immediately in a high salt buffer such as RNA later. It's also important to note that RNA is notoriously delicate. Even experienced scientists find it challenging to work with. To improve RNA quality, it's best to collect very small tissue samples, even dividing tissues into smaller pieces if needed. This helps to preserve RNA integrity and ensures more accurate results. When combined with fisheries science, transcriptomics opens up countless possibilities, from fish health assessment and monitoring to diagnostics, cost-efficient screening, early stress detection, and even non-lethal sampling approaches. If you're considering transcriptomics, start with our interactive fish health assessment decision guiding tree. This tool walks you through a series of questions tailored to your goals and constraints. By the end, you'll be guided toward the best options available to you, along with our expert recommendations. If a GenFish STP chip is the right fit for you, you'll have access to several pre-designed chip options targeting different species, taxonomic groups, or specific gene functions. To learn more about the use of omics in Canadian freshwater fisheries and conservation management, and for access to our database, tools, and resources, be sure to visit genfish.ca and click on the Omics Applications and Fisheries panel, or simply scan the QR code on the screen. Finally, we ask you to take a moment of your time to scan this QR code and complete our short omics survey.